So how are we doing? Any any questions? Anything? No, this is all. I do have to comment that the, this is you guys are uh, doing much better than all of the recent classes I can think of. So I mean, it, it presents a kind of a conundrum for me because I mean, if I were to have to give grades here, I would give everybody an A because you're all killing it. Um, the problem is that the CS department doesn't let me do that. Or I could do it, but I get in trouble. So you don't want me to get in trouble, do you? Nah, the heck with them. Anyway, okay. So today I want to finish. I want to finish the implementation of the shape of those shape classes. I mean, in the process, we're doing a little bit of a peek ahead into how Java does displays things on the screen. We're going to kind of circle back to that a little bit, but the main point of this is to demonstrate class hierarchies, to get acquainted with abstract classes and kind of what that's about and why, and to the to how these things are designed, and actually kind of why what do you put in the superclass and what are in the subclasses, and that's not a hard and fast rule, but there are some guidelines for that. And then we're going to talk about interfaces, which is an important idea in certain contexts. And actually, what I want to do here is something a little bit different than what the book does, but is kind of useful in that I'm going to refactor it a little bit, create an interface, and then have the base class implement the interface. So very common pattern, one that I've used a lot, which is to have an interface, to have an abstract implementation, and then have subclasses refine it. And then just as kind of as we go along, they're going to be sort of the topic that we're reading about, but there are some things about how Java does business that are important to understand, and in particular, how Java passes arguments to its methods is something it is, how should I say, it's because Java does it a little differently than many other languages, especially C and C++. It's important to kind of understand that. What they did was they made it a lot simpler, but there is a little gotcha which we'll show you. So okay, again, interfaces, and one of the things about interfaces is that that's how Java does kind of this polymorphism from the context of taking on different roles. In other words, and we'll see sort of what I think is kind of a cute example of that. And then briefly, how Java passes its arguments. The phrase that I find useful to understand is its copy of value, and what are some of its ramifications. Okay, so last time we had pretty much we had implemented this abstract class. We'd implemented this and implemented the circle. Didn't do the square, but if you do a fresh pull on the class code, you'll see a bunch of stuff. So the square is pretty much similar to the circle. So with the circle being extending the one-dimensional shape, and that one dimension being in this case the radius, and we should start. So to maybe clarify kind of what is expected in, in terms of the Java doc. What is the purpose of the documenting anything? It's so that you, if somebody is reading this, whether it's the Java doc or the comments within the code itself, is that they can understand what the intent is. Remember, for me, the prime directive is programmer's intent. So for me, this name dimension is kind of wonky, but for a one-dimensional type of thing, like a circle or a square or like an equilateral triangle, I mean, those would all be different things. For a circle, it would be the radius. For a square, it would be the side. So there's no one name that can kind of fit that. So here, like the comment on the constructor, instantiate a circle with a given location and radius. I mean, that's really all you need. To give some clue as to how you're doing it. So in this case, we're drawing the circle actually, and then we're using, I say use the fill oval to draw the circle. So that describes what's being done, but doesn't give all the details. So, okay, so that was the circle that we did yesterday, and then just really the square is pretty much identical to that, except that we're using the fill rect method. So this graphics thing has a whole bunch of fill type methods. So we have fill arc, oval, polygon, rect, round rect, where the book has the round rect thing. I'm not going to do that. But how do we, where do we do it? Well, we have the location, which is the x and the y. And then in this case, because it's a square and dimension was something that was in the abstract superclass one-dimensional shape. In fact, one of the things about one of the nice things about an IDE is I can right-click and I say navigate to the source, which will take me to where it is. And in this, we can see that again on a getter, normally if the getter is simply returning the variable, then you don't need a lot of comments, especially if the variable is well named. If it isn't, or if it does something that's a little bit different than that, then you want to say something about it. So here I'm saying I'm using the dimensions variable in shape, and in fact, I probably should have said, been a little more specific. Okay, so that, and then notice I'm referring to the variable, but using the getter. I have to use. Do you see why I have to use the getter? Why can't I just write this in the code?
Because that variable is a private variable in the class.
Yeah, exactly. Dimensions is a private variable in the shape superclass up here, and the key thing to remember is that private, anything that's declared to be private, whether it's a variable or a method, the only things that can access that directly is within the class itself. So private is just locked up tight inside the class. However, that variable exists in all of the subclasses. It's there, you just can't see, you can't directly see it. So if you have, in a situation like this, where you want somebody else other than yourself to be able to see what this is, that's what a getter is. So the getter allows somebody to get this value, but it doesn't allow them to touch it. So let's go back to where we were. Okay, so there's the square, and then I went ahead, and again, just so I don't, how should I say, it's like the last thing you probably like to do is kind of watch me do this, but Okay, so here's the two-dimensional shape, and that was, okay, the two-dimensional shape now has the two dimensions, if you will, but they're really the height and the width. And so, so I added setters and getters for those as if there were a height and width variable, but there isn't. So, so the get width is going to return the first item of the dimensions, and then the second is going to return the one at index 1, which is the second one. And then, let's see. In order to, so I'm passing two values, and so I can set my dimensions, but this setter requires an array, and again, I'm cloning it, but that's an important thing to protect the encapsulation of the array. So I create a new array, give it the width and the height. The width is going to be the first one, the height the second one. Arbitrary. If you like height and width, then just as long as everything is consistent. Okay, that's, and then a subclass of that, okay, one of them was rectangle. So the thing to make it concrete, we need to implement all of the abstract classes, abstract methods. And so the rectangle, there we are. Okay, we need there's a constructor, and we're giving it a width and a height. And then using the draw, there's a fill rect. Oops, I used the wrong one here. And then since JavaDoc this is HTML, so if I'm referring to code, sometimes you know you don't have to be. The thing though is that the JavaDoc tool that generates this now is very kind of anal about it being proper HTML. So. In particular, you have to kind of use some of the HTML codes for certain other things. So, for example, angle brackets. Like if I'm saying in the comment, this variable has to be less than 0 or greater than 0, I can't use the angle because the HTML sees that as you know, enclosing tags. So I have to use the GT thing. So you're all familiar with that, right? I mean, you've done HTML stuff. Okay, so that's okay. Fill the rec, and then the area is just the width and times the height. And so if we kind of run that, in this case, it just kind of looks something like that. Now the the thing to understand about the geometry of computer stuff, which you've probably all seen, is that the way that they do it is the origin is in the northwest corner. So this is 0, 0 up here. X goes in the normal direction, so increasing going this way, but Y goes downward. You're all familiar with that. Okay, so now the location is actually in the northwest corner of everything that you draw. So when we set the location, for example, for the rectangle, that set it to here, and then everything was drawn from there. For the square, it was set to here. And then for the circle, it was actually set to here, so which was kind of, you know, odd. So for the location of the circle or ovals and stuff is always outside of the shape itself. That's just the way it is. It's set to the northwest corner of what's called the bounding box. So the bounding box is a rectangle that would enclose this shape. And the quote location is in the northwest corner of that. Again, we'll kind of come back to that. But just to, okay, so I didn't do the oval yet, and so, how should I say, it's like, back in the day, when, kind of before all these fancy ID stuffs, you had to kind of type in everything by hand and then have to wait till the compiler picked out the errors and stuff like that. And so there's a lot of things that you have to do, but when we're subclassing an abstract class, the IDEs, and whether the Eclipse one that the book likes, and there are commercial ones that are even fancier, like IntelliJ and other types of things. They provide a lot of stuff where you're just kind of clicking instead of typing. Clicking is always superior to typing, because when you type, if you're like me, there's a lot of fat fingering going on. Okay, so let's, I just want to do the last one, which was going to be the oval. And now we do have to do a little bit of typing on this. So this would be a two-dimensional shape. And then, so I think we have to do a lot of typing, but in fact, in this case, since we're subclassing an abstract class that has abstract methods, they give us the choice, as we had before, of either making it abstract or implementing the abstract methods. So in this case, we want to make it as concrete, and if you want to make it concrete, you implement the abstract methods. Then notice that it's throwing an unsupported operation exception. So what that means is it's generating, I mean, it doesn't know what you want to do with this. And so, and this is actually a very nice thing. If I'm implementing something which has if there are a lot of these going on, then this kind of makes sure that I actually implement all of them. Because let's say I had like 6 methods I need to implement, and I forgot to implement one. Well, when I run it, as soon as they call that method, this exception is going to get thrown, and it's going to say, hey, you didn't implement that method. And I'm still getting red squigglies, and it says, okay, and then with red squiggle, your first, it doesn't always work, but you almost always, the little light bulb NetBeans has an idea of what to do, and their idea is to add a constructor. Okay, so basically, with a couple of clicks, I'm now gotten rid of the red squigglies. So that's a good thing. And then because the super class is actually taking care of, again, I can navigate to the source here. And so it's taking care of setting all that. So all of that is taken care of. And all I need to do is implement the draw and the get area. So the area is the easy one. What is the area of an oval? What is it like? Something like that. And then, okay, a little red, can't find symbol. The go-to thing, if they can't find symbol, is to, fix imports. In this case, they got a pi there. And then for the draw, remember that it's just for convenience. And it turns out that, graphics, I have a fill oval, which is very nice. And so I have to cast my but the 0.2D, which is far superior to the 0.1 that the book uses. And then the width, and get height. Oops. And now, one thing that this is, notice that in the Java doc, they describe the parameters. The x-coordinate, upper left corner of the oval to be filled, the y-coordinate, the width, and then the height. So the one thing that isn't, 100% obvious is I have the first two ints are going to be the location. Is it going to be x and y or y and x? And then the next two are going to be the width and the height. It's going to be the height, width and height, or the height and the width. Again, it's not obvious. It's an arbitrary choice that whoever wrote this made. And so just as a final thing, let's, where are we here? Oops, no, I want an oval. And where should we put it? Let's put it at 600 and maybe 200 to fix that. And what are our width? Let's make our width 150 and the height be 100. And let's see if that worked. Okay, so it showed up. Okay. Okay, so that's so basically implementing this class, this class hierarchy here. The advantage of these, UML is a very, if you kind of Google it and stuff like that, there are a lot of things to it. It's a very complex, it's a language in itself. A lot of it is kind of a little overkill. For me, these class diagrams are the most useful thing that I found in it. Why? Because we can kind of lay out the structure of our classes and do a lot of thinking before we start to write code. I mean, if you're anything like me, my instinct is always to kind of rush to writing code. And the more that you do this kind of thinking, sort of, planning it out, the better it is. Because once you do that, it's like the only code that I really had to do any work on were in these things right here. Everything else was just like very pro forma. Okay, so here's done a little, okay. Now what I say, the accessibility, I don't mean like accessibility. So just as, okay, here's the thing. We noticed that we can declare a variable to be of anywhere in a class hierarchy. In other words, I could declare my rectangle to be a rectangle, I could declare it to be a two-dimensional shape, or I could declare it to be a shape. My rule of thumb is that it usually works out best to declare the variable at the highest level of abstraction. That gives the most flexibility. If you notice in this panel that draw the shapes, I don't have to know or care what type they are. I don't have to keep separate variables for the ovals and the rectangles and everything else like that. And the disadvantage of that is that when I add a new shape, as I just did, and I wanted to use this to draw it, I'd have to go in and add another array that would be the ovals. And then I'd have to add an oval, add a rectangle, and instead I add a shape because they're all shapes. I can keep an array of shapes, and because every shape has a draw method that gives me a graphics, then I just buzz down those shapes and just draw each one. And at this point, I don't have to know or care whether it's a one-dimensional shape or a two-dimensional shape whether it's a rectangle, oval, square, anything I've created. And if I create a new one, I can I won't have to touch this code at all. So, editing code is bad. So once I have it working and doing what I want, then I don't want to touch it. Yes?
With that, if you're declaring it as a shape, and the shape draw method is abstract, how does it know which concrete draw method to use?
Glad you asked. Great question. If I'm at the point of invoking a method, I can't invoke a method on an object that's actually null. Otherwise, I get a null pointer exception. So the only way to actually invoke one of these abstract methods is on an instance of a concrete class. So how does Java know? Well, when Java goes to invoke the draw method of a shape or of anything, first of all, it has to be one of these concrete objects. Now, at that point, it doesn't know which one it is. So what does the virtual machine do? It says, okay, first of all, the draw method has been invoked on this object. Okay, so even though in the class it's a shape, but in fact it's say if it's a rectangle, it's in fact a rectangle. That's the object that has been done. So the virtual machine says, all right, since I'm running, that means that every method has been passed by the compiler as being able to work. The only way for that to happen is for the draw method to actually be implemented. So the virtual machine doesn't look at the type that's being declared, it looks at the actual object that is sitting there. And so if that object is a rectangle, it goes to implement that. It says, okay, go to draw, rectangle has draw, boom. Now, in the process, let's look at another one though. Let's look at well, supposing I wanted to ask the rectangle what area is. What does I say? So I say get area. So what does the virtual machine do? The virtual machine will say, okay, I've invoked get area on the rectangle. But, okay, yeah, no, that's no good. Supposing I want to ask it what its width is for whatever reason. Now, the rectangle doesn't have the method getWidth. So the virtual machine says, okay, the getWidth method must be in the superclass. So it'll look for it in the superclass. And if it finds it there, okay, I found it. If it doesn't find it there, it's going to look in that superclass. And if it doesn't find it there, it'll go all the way to object. So now notice that I haven't done any toStrings in any of these. But if I go to print one of these objects, it will invoke the toString. It'll say, okay, rectangle, what's your toString? I don't have one. Okay, well, two-dimensional shape, where's your toString? Don't have one. Shape, where's your toString? Don't have one. Object, where's your toString? It has one. Okay? But the important question, important to understand, that's how the virtual machine does things. In other words, even though the variable was declared to be a shape, when it gets to actually executing this line, this draw method, the only way that can happen, if this is declared to be abstract somewhere, is if there's a concrete implementation of it in a concrete class. That is the only way for this to happen. Okay, so, all right, so. Now here's sort of the catch. Here's sort of the other side of this. If I declare a variable to be at a higher place in the class hierarchy, and then instantiate it lower, any methods that are in the subclass but not in the superclass, I cannot directly invoke on on this variable. In other words, having declared rectangle has a method, well, as a two-dimensional shape, it has a method called getWidth. But if I declare it this way and then try to invoke getWidth on this variable, the compiler will not let me do it. So even though this object actually has it because it's a rectangle, because I've only declared it to be a shape, I cannot directly invoke that method here, because it says, hey, all you claim to be is a shape doesn't have the getWidth method, so the compiler will give it red squiggly. Only the methods that are declared here in the declaring variable can be directly accessed. So that's kind of the dark side of declaring things at an abstract level. Now, this is not canon, cannot. Now, the thing is that if I instantiate a rectangle and assign it to this variable, those methods are there. They are there, but I just can't see them directly. I can do it if I cast, in this case, if I cast it to a rectangle, the virtual machine will say, okay, I'm going to assume that you know what you're doing. And so if you cast this to a rectangle, it says, now I'm going to coerce this variable to be a rectangle. And oh, by the way, the rectangle class does have a getWidth, so this will pass. So what can go wrong? Well, between this and here, I can declare I can instantiate, say, a circle and assign it to the variable called rectangle. That's perfectly legitimate. And then when I go to do this, I'm going to get an error. Why? Because there's no getWidth method in circle. So that's not going to work. Okay, so important to understand that. Okay, on to interfaces. So the interfaces are, they're like an abstract class, but they have no state. They have no variables, and all they have are abstract methods. Now, this was one of the great appeals, to me at least, of Java. This was something that actually, I'm not sure what the first language actually do have this concept, but Objective-C, which was my first object-oriented language, had this concept, and it was a very important one. And the idea is that all an interface does is this says, these are the methods that these objects are going to have. In other words, it's like a contract. If you implement this interface, then you've signed a contract to implement those methods. And therefore, if you use an interface as a type, then you can invoke any of those methods declared in the interface. So the key word is interface instead of class. So far we've had three things. We have classes, we have enums, which are actually also classes, and interfaces, which are different things entirely. An interface is not a class. You can't instantiate it. It's just a contract. This is also what's used for polymorphism, the other frame of that. That is, classes can implement multiple interfaces. You can only inherit one class, but you can implement as many interfaces as you want. The UML diagrams typically look like this. Ideally, you sort of specify that something is an interface. Because it's abstract, then it's usually put in italics. The implementing class then has like it's the same little arrowhead, as subclassing, except that you use a dashed line. And then this is if I have two interfaces, I can have an implementing class that implements both of them. And in a way, it's kind of the inverse image of inheritance. See, with inheritance, if I subclass something, I get everything in that superclass. I get it all, even if I can't see it directly. So subclassing adds. Interfaces are kind of the opposite. In other words, if I subclass something, I have to do less work because I don't have to do all the work that I've done in the superclass. If I implement another interface, then I've actually added to my work because I now have more stuff I need to do. So, but this is how how this was done. So, this is now you can ask your grandparents about old Saturday Night Live in the first but they had this. I should put a link to the little thing. So they had this ad for where a couple is arguing about this product, and one says it's a dessert topping, and the other says no, it's a floor wax, and they say wait, you're both right. It's a dessert topping and it's a floor wax. Okay, so let's say we have one interface, dessert topping, and it has one method called eat. And again, this is abstract, so it just says you need to implement something called eat. And then here's another one where it's a floor wax. If it's a floor wax, then I have a method called wax the floor. And so their product, which was called Shimmer, implements both of them. And so it says we can either eat it or we can wax the floor with it. So okay, that's a little. This is a this in particular. Here are two standard patterns for these things. This is one I use a lot. This one not so much, but they're both valuable, especially this one. So what's useful is by defining the interface, you sit down, you say, okay, what are all the things I want this to do? What are all the behaviors? And you don't have to worry about how it's going to happen. You say these are all the behaviors the object is going to have. That's going to be the interface. Now, of those behaviors, some of them I can implement for everybody, and some of them I have to leave. I have to kind of make abstract. And so, an abstract base class implementing an interface will typically implement some of these, but not all of them. And so a concrete subclass now needs to implement all of them. So here's an example where I'm going to refactor the shape thing. So I'm going to the book does something similar with something about transposing them, which is kind of okay. So, but just in the context of what we're doing here, all those black colors, which was kind of the default, okay, that's kind of a little boring. Let's let each shape have its own color, right? So I'm going to create, and then because I'm going to create an interface, I'm going to call it drawable. So something that's drawable, I can draw, and I can set and get the color. And so my shape class, which is going to be, here, this is some cruft from my drawing program. So for my shape, it already had the abstract draw, so I actually don't even need to declare it there anymore. But now for each shape, I'm going to have, every shape is going to have its own color now. And so I can implement these, but not this. And then carry on with that. So what does that look like? Before let me commit. Again, remember, commit early and often. And I'm just committing locally. I'm not pushing yet. But what that means is that if I kind of get wrapped around the axle here, I don't have to kind of go back and figure out what I did or didn't do. I can just kind of throw all that away and I'm back to where I am now. All right, so how do we define it? Well, if I define a new, in this case, Java interface, if it's not there, I can go to other, and here's Java interface. And as the book points out, a lot of interfaces have the ABL, in this case, drawable. So a drawable thing is something I can draw. And then all I do is, and again, this is directly from the UML diagram. Oops, I need to. Yep. And okay, red squiggly, when they can't find the symbol, the go-to thing is to fix the imports, and we're using Java's color thing. So oops. And then the draw one. Okay, another red squiggly, fix imports. Okay, so we get that. Okay, so the just as with the abstract classes, in an interface, these are all just abstract methods, meaning what I'm saying is that if you are a drawable, then you must implement these three methods. Okay, so now, so how do I use that? Well, now I'm going to say public class shape implements drawable. So the key word is implement. And since shape is abstract, notice that no red squigglies. Now, if it were not abstract, it would complain and say it's not abstract and blah, 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 okay. But I do want to implement the set and get things. So I'll add color to the mix. Need to fix the imports of that. I'll do the setters and getters. For set, and then where shall I put them? Let's put them down here. Set and get. And then actually, what I'm going to do, where are you here? Where's, shape, da-da-da, okay. I actually don't need to do this anymore because it's still there. So what, now, okay, so now if I run it, nothing is going to change. It's going to be the same. Why? Because I haven't really done anything here, but what I can do is I need to, let's see, in the draw method, I need to, I'll do it on the draw panel here. And here's how I can do it. This is how. Okay, so what did I do here? So the way that Java draws stuff is that there's this thing called a graphics context, which is a graphics object. And that's the thing that actually did stuff. And if I'm going to draw something of something other than the default color, I need to actually explicitly set it. And So I set the color, and now I can get the color from my shapes. Why? Because get color was actually implemented somewhere in the class hierarchy. I actually don't know where. Actually, here I actually know that get color was implemented in the shape class because it actually works here. And then, okay, so let's kind of use that. Where's my darn thing here? Okay, so let's circle. What color do you want the circle to be? All right, they want it to be yellow. We'll make it yellow. So square. Set the color. Oh, let's make it red. And they have both lower and uppercase things, but you really should be uppercase. So angle, set color. And set color. Let's see what oh, we haven't had a blue one. All right, so now when we run it, each of them are going to be the color that I said it was. And that's notice that the way that the class hierarchy and stuff works is that it's very there's not a lot of code. There's a lot of things that I have to do. I mean, there's a minimal. The ideal thing in anything with regards to programming is there's a certain minimal amount of work that you have to do in order to get stuff done. And then there's so the optimal amount is enough to just get the job done, and then any more is just kind of non-optimal, let's just say. Okay, so each shape knows what color it is. The draw panel didn't know or doesn't have to know what that is. It just says, give me whatever color you are, and I'm going to set that to the graphics context. So, and here's just another implement. Oh, and in case you're, I noticed that in these, notice the background here is white. That's not the default. If you want to change that, you can. You can set the background to white. Oops. Or whatever. Why didn't you? Oh, so, I think I have to set opaque. Huh. I don't know why it didn't do that. It's supposed to do that. Anyway, well, that's not important. Okay, so let's see. Didn't get to this. I'll start with this tomorrow because this is important to kind of understand how that goes. So, all right. So that's it for today.